it together. I can share my screen. So right here. So does everybody see it? There is a Julia download. I put it in your Blackboard. I mean, I did it beginning of semester, but I'm doing it again. And also, in case you want to know more about Julia programming, there is a free academy that you can take class. Okay, it has all kinds of stuff. In fact, let me show you. So this is the basic Julia's. It will tell you how to use it. So I mean, I finished this one. I thought it was a very good class and easy to do. So I'm giving you this project because not just for the calculus class, but you will take more science classes, okay? Which means you need to have some kind of program skill. And then Julia happened to be very friendly to math and very friendly to statistics, any kind of science related work, okay? Like biology majors, chemistry majors, well, computer science majors and math majors, okay? Anybody who need to do any kind of calculations or report or statistics, Julia is a very good language to know, and it's free, and it has a lot of resources. As you can see, they gave you beginnings, the basic tutorials that you can just watch. Not just that, if you look at their Julia Academy, then you will see data science. You know, data science is a very, very hot topic right now. Everybody know about the data science. And now, of course, you know, the COVID-19 is, it's in our mind and it's still happening it's a current problem. So there is something they did, the computation modeling using Julia to do COVID-19. And then there's a people like to do about machine learning, and Dr. Chris, he is MIT professor. He's an extremely, extremely smart person. He did this one, Foundation of Machine Learning, and the data frames, and there's other Julia Academies, and there's all kinds of stuff here. So I want you to look into this, okay? Because calculus is not end of your science class. Calculus is not end of your goal, okay? Your goal has to be further than that. Calculus is just the foundation of your goal, that a foundation of your, it's just a step to meet your goal, okay? So make sure you learn this. So that's why I'm not gonna give you any other lesson this week. In fact, I'm not gonna give you a lesson on Tuesday either, because I want you to concentrate on learning Julia and writing a program. The program that I ask you to write is a very simple program, just Newton's method. Okay, you may write in many different ways. Okay, but I did give you a simple, I did give you the simple, let me see right here. I sent you an email yesterday. So, you know, this is just simple things that you need to have in your program, right? Your program, I want everybody to call the exact same name, so I know how to grade easily. So I don't want to figure out what you call your program name. So I want everybody to call your program, your function, to be Newton method, lowercase n and uppercase M, okay? An argument of the Newton's method, the function will take 4 arguments, the starting value, and then function, and function prime, and then tolerance. What do you want your tolerance to be? How close the new number with the original number, okay? The original x to the new approximation x, and see how close you want to be. I usually want it to be like 0.005 or something, okay? And you're gonna do your numerical iteration as long as the absolute value of the 2 x's is less than tolerance. Okay, then you can keep doing it. Oh, so you actually, I made a mistake here. Let me fix it. It should be what? You're gonna do as long as what? Bigger than that, not less than that, right? So this is actually wrong right here. Because you're gonna keep doing the if statements as long as your new value minus old value is bigger than tolerance. One is equal to tolerance is probably fine. Bigger than equal to tolerance. So that's the what you need to put. Okay. Putting out the solution when this is correct, when absolute value in this is less than equal to tolerance. So that is correct right there. You can put equal to it. So you can also stop when it's equal. There's hardly ever be equal, but in case does, yes, you can stop. Okay. So you can watch the video that we did. Okay. And this is what we're going to use. Using plots. I want you to using plots to see. Okay. So you get to see. So these are the steps that I probably want to do. I want you to do. And using plot. And then I want you to also set what plot, next an F. So you will see using this, you will see a graph. And this graph to find a X naught. Okay, in this case, we chose X naught to be that. And I'm going to use tolerance to be 0.005. So looking at this, okay, it will help you to write your program. So I gave you a hint what to do. Okay, this is a guidelines I gave you. Okay, and then the sample problems I want you to try is this, F, the one that we did yesterday. Type this in your Julia. Okay, type that in your Julia, then you will see what I'm talking about. Okay, so put that in your Julia. And then your program looks like this. Okay, I made a mistake here, right? So I need to fix it. So it's in your Blackboard. So your semester will start, your project will start like this. And you're gonna say, okay, this, and now you're gonna change that into greater than equal to tolerance. If then you're gonna do that. Okay, so this means over here, you have a function starts with a Newton method, taking a 4 arguments. And then you're gonna say if the absolute value of a new value minus old value is less than equal to tolerance, okay, less than equal to tolerance, then you're gonna write your code here. Okay, you're gonna write your code. So I gave you beginning, I gave you end. So you need to write your code right here. Write your code. Okay, then you're gonna end, return end. So this is what you have. So I gave you basic frame. So you need to think about it, what to do. All right, next thing, so we can go back to Julia again. Okay, you remember? Okay, so students, class, if you have a problems, as I said before, this is the time you gotta use your peer leaders. They are trained to help you with this project. Okay, they took Julia Academy during the summer, so have done all this. So talk with them and meet with them. Okay, this is the time you have to work with them. That's the reason that I hire peer leaders. So if you have a problem with any Julia problems, especially ones you never programmed before, work with them. Okay, you need to get some kind of skill. Okay, this project is just not for the calculus class. I'm telling you again. This is for your future goal that you need to meet. As a scientist, okay, you're a science major, math, computer science, biology, chemistry, physics, you're science majors, okay? You got to know how to program in at least one language that you be comfortable with. So I'm giving you the easiest language to learn. Like as a math person, I use Julia for almost everything. Okay, so I'm telling you already, giving you a heads up, so you can be more prepared. You can compete with other people, not just for the UAPB. You go out, you go get a job. You want to make sure that you be better. Okay, you be well prepared. You know how to do data science. You know how to program at least one language. So choosing Julia would be a very good choice for you guys as a math person, as a science person. And computer science major, I understand. But also get to know Julia.
That's where I did it. I was working with Micaiah this morning, but we couldn't figure it out. Like I tried it like 3 different times, and all the time it said error on it.
So what language did you use? I mean, what computer do you have? What kind of computer?
HP.
Okay, so you have a regular, you don't have a Chromebook, but you have a regular computer, right? Do you have
Yes.
a,
Do I have a Chromebook?
yeah. So do you have a regular computer?
Like a desktop or something?
No. The Chrome is that you cannot download, you cannot install any softwares because it's all cloud based. So you all
Yeah, it's a regular computer, not a Chromebook.
okay. So it's a regular computer. That
Yes,
means it should work. So what do you do? Talk with James Quincy. He's a computer science major. He can help you to uninstall everything and reinstall in different ways.
okay.
Because sometimes, whatever the reason, you can corrupt your data. It happened to me, same thing. My Julia somehow just stopped working. Somehow it got corrupted. So I had to uninstall everything and reinstall it, and it worked. So try that too. Okay. All right. Anybody have questions about Julia? Okay. Have you looked at it? Okay. Let me just emphasize one more time. This is a 10% of your grade. I make this to be a huge amount of your grade because I want you to learn at least one computer program language. This time it's a Julia. Okay. So this is not just a calculus class matter. It'll be your future also depending on, because you need to make sure you have some programming skill. Let you do it now. Okay. Better to do it now than later. Okay. So learn this. I'm asking you again. I gave you resources. Look those, learn those. Okay, now let's look at Julia a little more. So, does everybody understand yesterday what we did? Remember, yesterday we said, let's try, I'm gonna just restart this thing and then so you know, so you be all same, be on the same page. Okay, now I'm gonna share. Okay, I'm gonna start a brand new one, like yesterday. So the blackboard that I put in a blackboard, remember I said, go to Julia, type this. So I'm gonna do exactly the same thing what I told you to do. What was the thing that I asked you to do? Let me see. Okay, we're gonna start with our program. Right, so it says do this. I'm gonna do what we practiced yesterday. So we're gonna do, by the way, did you see I put the dot? Not just say x square, but I put x dot square. X dot square means I get to evaluate many x's at a time, not just one value at a time. So which means it's broadcasting, it's a mapping. So let me show you what that means. So we do that first, right? Enter that, and then I'm gonna say x is equal to -5 to 5. So it gives me that. Okay, now look at this. I can evaluate all my x's by doing that. Wait a minute. So where did I make a mistake here? It does not let me, Okay, it does not like me having that axis with a, whatever the reason, I will figure this one out. So you can only, right now, whatever the reason, I can only do one value at a time. Okay, like this. Okay, I can only evaluate one value at a time. Only one value at a time, but it's supposed to work as like this. That I get to evaluate all 5 values. So I will probably, I will let you know what I made a mistake so we can do this problem together. So right now, the one we have is, let's go back again. So we're gonna just type this. We have that. And then we say we're gonna choose X to be -5 to 5. And I say, let's use plot. Okay, that means I'm using Julia library to do plot. So I'm waiting. So you have this problem too. You're gonna wait because it needs to upload it. Okay, it needs to, I mean, the uninstall it so we can start using plot, the Julia built-in function. Okay, so it's finished. Now I got the Julia again. Then I can say let's plot X and F. Okay, I'm waiting. So whenever you don't see a Julia prompt again, that means it's calculating. So you have to wait. So I'm waiting for the program to I'm waiting for the plot to show up. Okay, there you go. So let me show you the plot. You don't see it, but here. That's the plot, looks like. That's the plot from -5 to 5. And this is your 0 line. Okay, you see the 0 right here. So that's your plot line. So this is what your graph looks like. And by the way, unless I told them to change my scale, it just do like this, like a box plot like that. So you need to realize that your 0 is over here. Okay, did you everybody see it? The 0 line is right here. So that is your solution. All right, those are 2 our solution. So looking at this graph, I don't want a solution right now. Remember, I'm trying to practice approximation numerically. I'm finding my solution numerically using approximation, okay, Newton's method, approximation. So what do? So you can choose number right here. That'll be my X naught to be 3.5. Okay. That's what I'm doing, choosing an X naught to be 3.5. So I chose that to be X naught, which is 3.5. Okay, that's the reason that I chose 3.5. So this graph gives me an idea what number to choose as my beginning number. Okay, so now let's go back to my other graph. So you have that plot. Now I finished the plot now. So okay, I'm gonna say, okay, I want my X naught to be 3.5. I got that information from plotting. And then I'm gonna find my F prime, which is 2 times X minus 5. I'm gonna give them a tolerance, which is 0.0001. That's what I wanna give. So these are the ones you need to find it before you write your program. So your program writes like this: function, Newton method. Then you're gonna put x naught, f prime, and tolerance. That's what we're gonna put. Okay. As you see, it asks you to finish your program because you didn't finish it. That's why it's giving you prompt, but not a new cursor called Julia. They're telling you, okay, you're still writing here. So I'm gonna say this is place I'm gonna write. Remember, I gave you this much. X new, then you're gonna say X new is x0 minus f of x0. I'm evaluating x0. And then I'm also evaluating f prime of x0. I got that one. Next one, then if absolute value of x new minus x old is greater than equal to tolerance, okay, that's the part you're gonna write a program. Okay, you write your program, and then when you're done, you're gonna say and. Okay, you're gonna write down whatever you're gonna write down. Okay, you need to write down something here. The line right here, you need to write down your code. Okay, and then you're going to do return x new and end. So that's what you have to do. So this is how you write your program, and you're going to say end. So my program, I wrote it here. That you see the sharp and say write your code. That's the part you need to write your code there, and then you'll be done. So is everybody following me what to do? So if I evaluate right now, it will not give me a right answer. It doesn't give me what I want. Okay, I put Newton's method. So if I want to call Newton method, I'm going to put x naught, f prime. It'll give me a number, which is 4.125. This 4.125 is what you calculate over here, this number. Okay, x new, that's the first one. When you do your first iteration, that's what you get, 4.125. But I'm not done yet, right? Because I didn't do my coding here. Write your code here. You gotta do your code so you get a correct answer for your answer. But this is how you use it. Okay, this is how you call your function to answer that you want. So I give you different function, and you're gonna put different numbers here, x naught, f, and f prime tolerance. Just put a different number, it will work. So this function is supposed to work for any kind of equations that I give you. Okay, this Newton's method function, that the program that you're gonna write is supposed to work for any kind of math functions I give you, and you will let me know whether this is correct. I mean the answer for that. Okay, so if you want to get a bonus problem, I want you to also put a conditional statement says, if this is not allowed, if you cannot use Newton's method because this function does not have a solution, then you need to put it down there. Say, give a conditional statement says, if, so you can say there's no answer, there's no solution to this function. So you can put that in as your conditional statement. I can give you bonus problem for that. And bonus points for that. All right, so I'm gonna stop right now. So if you wanna put screenshot, but you can just watch this also if you want to, okay? So I will stop now. So any questions so far? Is everybody good? Okay, I need to hear your feedback. So anybody have any questions? Or, okay, Thomas, do you have any questions for me? The ones that I just went over today.
No, ma'am.
Shalia?
No, ma'am.
Okay, so does everybody kind of understand what to do? Because we're going to have a short class today. All right. So I want you to concentrate on this. your project needs to turn it in by Wednesday. I'm not giving you any lessons. That's it. Okay, in fact, Tuesday, I may not even give you a new lesson. So starting Wednesday, I can start chapter 5. Okay, integrations. All right, so if you don't have any questions, I'm gonna probably let you guys go. Can you tell me what we're going on the homework again? Okay, Chevian, homework, I gave everybody 100%, whether you got it right or wrong, because I look at your exam and it shows that you understand pretty well. So I decided to give everybody homework grade for 100%. So it will help you with your midterm grade, okay? And then end of the semester, I'm gonna put it in your bonus point that you did for algebra homework problems. Remember the algebra bonus problem? I will include that on your end of the year, end of the semester grade. Because right now we're still grading those papers. I don't know how many bonus points you're gonna gain. All right, that's a lot of worksheets. So we're still grading. So hopefully we finish by end of this month. So I know how many points I can give you, or I can let you guys know what your bonus points you're gonna receive. That's like on top of whatever you see on your Web of Science. The Web of Science shows 89, and you have a 3-point bonus points, then you have 8, because 89 plus 3 give you 92, which means you're making A. All right, the bonus point that you will get from the algebra worksheets will help you dramatically, because that's just on top of whatever the grade you have. All right, so your homework and your exam is already graded and it's done. So if you have a questions, you can stay behind and ask me. Otherwise, I'll probably let you guys go, and I will see you Tuesday. Make sure you do your homework and see your peer tier leaders, okay? I mean it, it's a 10% of your grade.